So I'd ask my panelists to come up and start to assemble onto the stage at the same time that I introduce Roberta Scerbo, who's the Director of Utility of the Future for Orange and Rockland Utilities. Roberta, welcome up.
Good morning. You're right, Micah, they're sleepy. Good afternoon. My name is Roberta Scerbo, and as Cheryl mentioned, I'm the director of the newly formed Utility of the Future organization at Orange and Rockland Utilities. First, by way of introductions, let me tell you a little bit about Orange and Rockland. I think we have. There we go. Orange and Rockland is a wholly owned subsidiary of Consolidated Edison Incorporated. We are a combination electric and gas utility with our headquarters located just 25 miles from here in the northwest suburbs of New York City. O&R has two subsidiaries, Rockland Electric Company in New Jersey and Pike County Light and Power Company in Pennsylvania. Our territory encompasses over 1,350 square miles and 7 counties in New York, northern New Jersey, and northeastern Pennsylvania. We serve approximately 300,000 electric customers in all 3 states and approximately 128,000 natural gas customers in New York and Pennsylvania. Our territory is primarily residential in nature with a broad base of commercial, agricultural, and industrial customers. As demonstrated by the tremendous turnout at this conference, this is a very thoughtful, very interesting, and thought-provoking time to be in our industry, finally. For me and my newly formed Utility of the Future organization, our focus has been solely around the work related to REV implementation. And as mentioned so many times here, that presents a lot of opportunities and also challenges. I'll start with some of the items that we consider potential challenges when implementing the transition to REV. It's said that anything worth doing is worth doing well. So I would say that getting it right, doing it well, and meeting all the core principles set out by the PSC and the REV initiative in a manner that's consistent with our statutory obligations is the current challenge. I'm certain, not unlike the utilities in the room here, that our priorities continue to be to maintain a coordinated, safe, and reliable grid operations. As a DSP, it's critical that we provide customers with increased levels of choice. But at the same time, as DER penetration levels continue to increase and never before seen changes are made to the way electricity is distributed and used in New York, we, the utility, must maintain our focus and ensure that we provide safe, reliable service at a reasonable cost to our customers. That being said, we also recognize that there are certainly plenty of aspects of REV in the newly envisioned utility business model that present great opportunities for all of us. For instance, it provides us with the potential to partner with third parties to test opportunities to defer traditional infrastructure investment through non-wire alternatives that could defer capital investments and avoid future utility rate increases. This is such as the project that O&R currently has going on in Pomona, New York. It also provides the opportunity to work with third parties to serve as a facilitator between our customers and those DR suppliers to connect them in a targeted manner to provide the best opportunities for our customers to understand their energy usage better and access products and services that will allow them to better manage their energy costs. And, importantly for us, at the same time, it allows O&R to take advantage of potential new revenue streams through market-based earnings. In fact, O&R's first REV demonstration project, which we filed back in July, seeks to further explore this very business model. Our first demonstration project, we intend to partner with Simple Energy and its network of third-party product and service partners to create a customer engagement and marketplace platform. Among the potential obstacles of wide-scale adoption of DER in the residential market is a lack of customer understanding of which types of DER are best suited to their energy management needs. Customers often lack the adequate information to take action without a targeted message or a streamlined offer. So our online engagement platform looks to address this obstacle by providing a method of matching high-quality energy efficiency products and DER service vendors with qualified O&R customers. By leveraging customer data and analytics, we'll provide the customer with personalized communications regarding products and DER offerings, and use all the various services that are available through the platform. We're also continuing to explore a variety of potential future demonstration projects. We continue to look for ways that would best serve our customers. And obviously, we're interested in pursuing projects that will allow us to explore new revenue streams and market-based earnings as envisioned in both the REV Track 1 and Track 2 orders. Ultimately, however, the intent of any of these demonstration projects is to explore and learn from the potential business models in order to shape the utility of the future. At least I hope they do, or I'll lose my title. So in turn, I'll turn it over to the panel. And they're going to focus on the utility's future role as the DSP and the new business models and partnerships that will optimize the value created for DER providers and utilities, and as Richard stressed this morning, most importantly, our customers.
Great. Thanks so much, Roberta. So here we are, after lunch, after good conversation and networking, talking about a subject that I know is near and dear to all of your hearts. We talked about buildings, we talked about efficiency this morning. How many of the audience have been worrying about platforms for DER coordination? I knew it. We had a hot subject here. All right. So, but I have spent several hours with the three gentlemen joining me on the stage talking about this subject, and we have more than enough time to spend our 40 minutes. So we're going to jump into this. Let me introduce to my left Sunil Cherian, founder and CEO of Spirae. Naimish Patel, founder and CEO of Gridco Systems. And Carlos Gonzalez, Senior Manager for Grid Engineering Solutions at SolarCity. All of which, are very much worrying about this exact subject every day and have spent a lot of time thinking about this. Our goal as a group here is to actually really frame up what are some of the issues and challenges with the whole idea of platforms for DER coordination. I think it is a subject that maybe is not as familiar to everyone, and what we thought we would do to start with is not just frame the issue, which has been in the agenda books, but that as REV envisions the utilities in the future acting as distributed system platforms, DSPs, they would be facilitating and coordinating the adoption of DER resources. And so, well, what does that mean, and where should we start that conversation? We thought as a group that maybe we should start and let each person take a look at, well, what's the current state of affairs? And then we'll build on that into the customer focus, the market focus, and the technology focus as we go through this. And I'd invite everybody, those listening on the internet as well as those in the room, please bring your questions in. And especially for a subject like this, if we don't get to all of them during this conversation, we really would like to think about places that we can use some of those things as seeds for further conversations, webinars, and other engagement, or you can just swarm them after at the break and get the answer yourself. So Sunil, why don't maybe give us your take on where we are today.
Well, thank you for the opportunity to be here. Probably the easiest way to talk about the state of the industry as we see it today is to speak a little bit about the types of projects that we do. Spirae is a company that develops control systems for integrating distributed energy resources. We do that for primarily with three classes of customers. One is distribution utilities. They use our products as DERMS, or a distributed energy resources management system. We have customers that are ESCOs, or project developers, or systems integrators that use the same types of solutions to bring in integrated solutions on the other side of the meter, so to speak. And then a third evolving class for us are OEMs that are trying to integrate multiple technologies and have very standardized offerings that they take to market through their channels as well. What we find today is that most of the projects are focusing on opportunities where the business case is pretty clear. And what that does is that you end up with a very disparate set of projects. So I can probably say that there's only a handful of projects that are similar in our case. There's a lot of diversity between the projects. So you end up looking at projects from a custom basis a lot of the times. So that's sort of the situation today. People recognize the value of all of the distributed resources, the need to integrate with existing legacy stuff and the grid, but at the same time, finding the models that bring in ways to standardize and scale, we're all struggling with that. That's probably also set the stage for this REV type initiative, where a lot of the intent or the objective is to standardize and find mechanisms to actually bring these things to scale.
Yep, to get them to scale. Naimish, you certainly have a view on where we are today.
Sure. I mean, as has been alluded to many times today, the transformation that needs to occur is really fundamentally customer driven. And it's driven not just by the customer, but by market forces, both supply and demand forces, whether that's learning curves of solar or learning curves of energy storage on the supply side, or the demand for solar, demand for EVs, fast charging on the demand side. And now, if we put that in contrast with the fact that the distribution system itself has operated since 1935 under a regulatory compact oriented to one service fits all, the differences become stark. So on one hand, customers demand an increasingly diverse set of services, but the distribution system itself and the incentives for utilities to invest in the distribution system itself are not well aligned with multiple services. So fundamentally, there's two things that are required to be able to accommodate this apparent diversification of demand by end customers. The first is a change to, in effect, the contract between utility and customer. That is to say, not only is it needed, are multiple services needed, but the pricing and underlying costs of those services need to be designed and regulated to not only maintain the reliability of the distribution system, which is still critically important, but also start to evolve to accommodate customer demand. Part of that is a platform, which is what this panel is about, to evolve that distribution system into what I like to term a competitive energy exchange. That is to say, a system that is more adaptive to change at the endpoints where the customers reside. And that adaptability needs to come in two ways. The first is in the underlying physical infrastructure, the hardware that regulates power flow. That needs to become much more adaptive and dynamic in its operation, unlike the mostly centralized controls and electromechanical devices that the grid has come to rely on over the last 100 years. And then the second piece is a set of software, you can call it a grid operating system if you like, that operates in an increasingly decentralized way to be able to scale and manage an increasing number of endpoints under the control of a distribution operator. So those are the two pieces that, in our view, are necessary to build this platform.
Yep. And Carlos, what do you see state of the art today?
Yeah, absolutely. So first of all, just wanted to mention SolarCity is a firm believer in comprehensive load management, load shifting, and also whole home energy management. We think that those smart energy homes, when you aggregate them, optimize them, and utilize them, you can actually have an asset to the grid that can bring value to the grid. And those capabilities are here today. So we're pretty excited. For instance, the most recent pilot we have with Southern California Edison, we're aggregating controllable loads, batteries, and solar to do exactly that. When I think about where we are today and probably the three areas where I think we can make most progress in the near future, I would like to touch on at least three aspects. One of them relates to sort of like the procurement paradigm that we're under, and sort of like how you go about sourcing these alternatives in our current context, and also setting the right incentives for utilities to consider those alternatives. The second one is intimately related to that first one. It relates to operations and how do we listen to operations engineers at the utilities about what their needs. And sort of like what I want to get into there is, products that today perhaps like DR use them for sort of like emergency situations. How can you perhaps rely on those assets for more ongoing operations? And then the third one, I would like to echo some of the stuff that Sunil was mentioning earlier related to just the product specifications today, we are pretty encouraged by our conversations with the utilities and also seeing the stuff that has come out recently through non-wires alternatives proposals. I think probably the next step is the requirement there for resources to provide that need is pretty rigid. And I think we can talk about ways, and there's good points of reference that we can point to in other parts of the country or that have happened in different markets too.
Yep.
So,
No, good. As you can tell, we've got a lot of stuff to talk about. But so let's peel it back. There is a lot in this that's around supply side, I think. But let's go back to the demand side and start there, perhaps, with, well, what does this mean to the customer? Like, how do we focus on this? And as we go into this space, what does it mean to the customer? Naimish,
Sure. So, well, I mean, I think it starts at what's the definition of service to the customer. So if a customer has, for an example, electric vehicle and needs fast charging, how does one describe that service within a common framework that also covers services like if they want to feed solar back into the grid or feed wind back into the grid and so on and so forth. So it touches upon some of the things Sunil mentioned, but ultimately having a clear articulation and quantification actually of what that service performance and its pricing has to be is critical, and everything else derives ultimately from that. The interface to the platform will be derived ultimately from that. And it should be noted here that the way that we all pay our electricity rates itself needs to actually change in a relatively fundamental way, because today what we pay is ultimately denominated in kilowatt hours energy. But if you look at the underlying costs of the owners of the wires, the distribution operators, their underlying cost is increasingly dominated by fixed costs. And those fixed costs are proportional to the capacity of the system that they have to invest in to accommodate the load and now increasingly supply. And so, when you have a model, for example, like net energy metering, where it itself is denominated in kilowatt hours, in cases where there's a lot of adoption of solar, you end up with a strange scenario. You end up where the peaks in the system, the capacity of the system that needs to be invested in, ends up being more related to the supply, that is the inflow of solar, than the demand. That's actually occurring in Germany, that's occurring in Hawaii, that's occurring in California and Australia, many other places. And you see as a leading indicator that the net energy metering framework is breaking down, fundamentally, as you see this in the wholesale markets. You see negative energy pricing in the wholesale markets. You see routine backflow of power into the transmission system in California and Hawaii. So this is all a result of net energy metering being a relatively blunt tool for the compensation of feed-in of power. And so at the end of the day, what needs to occur is that whether you're consuming power or you're supplying power into the distribution system, it needs to be denominated, at least in part, in capacity, in kilowatts, not just in kilowatt hours.
Sunil, initially, the whole idea of the customer, when we started talking about this, was really something that grounds this for you as well. So how do you see the customer value proposition wrapped up in this?
Yep. Naimish already touched on most of that with the point that end users value different types of stuff, and we try to normalize everything around kilowatt hours. Right? So that's one of the fundamental things that has to change. So, but if you think about the electric distribution grid today, for the past forever, it used to be an infrastructure. It is an infrastructure for kilowatt hours delivery. That's how the models have been put in place. Right? Instead of that, if you think of it as an infrastructure for service delivery, where these services are the things that actually matter to the customer, whether it's electric vehicle charging or renewables or even cost. It could be a low-cost power, clean power. It could be comfort. Right? There are all kinds of different things that can be delivered to the end user. So the question is, this existing grid, how does that, how do we transform every stakeholder in this game to stop thinking about this as a kilowatt hour delivery infrastructure to thinking about it as a services delivery infrastructure? That's the fundamental transformation that will connect it to the customer. So what the customer chooses on the other side will drive where the innovation goes. At the end of the day, the copper that's buried underground is, well, that's just what it is, right? Not different at all from the telecom sector when we had, black telephones and an electric infrastructure underneath that, right? So that by moving over to a data infrastructure, the services part of it opened up, even though the voice part of it is still there, right? I mean, we hardly ever use it, but that's a different story. But it's the same situation. The kilowatt hour delivery should still be there, but the potential for that is to actually build on top of that with the stuff that actually matter to end users.
And so I was going to say, from SolarCity's perspective, Carlos, and
So perhaps taking a different angle at it, I would say one of the realizations for us has been that, for us who live and breathe these ideas night and day, it's easy to imagine that all prosumers perhaps want to be, managing their behavior every day and looking at gadgets, that do that. And perhaps one of the things that we should be also aware of is there are consumers or prosumers that actually would prefer to still be engaged, but prefer to have things happen in the background. So that has implications for what type of product you produce for them. So for instance, what's sort of the convenience factor, the simplicity factor, and sort of what's the expectation for them to have any interruptions if you're adding them to a system. It also has implications for how you design that platform at the end of the day. If you're going to be scaling up multiple consumers in the future, how do you need to go and manually go make resets on the ground, or is this something that you can actually remotely do, like software upgrades and so on? So I think those distinctions can really lead to different models and different product and different architecture for the platform you're looking for.
Absolutely. And so as each of you have grappled with this service provider and listening to the customers and coming up with how you're working today and how you see plugging into the future, would have been critical partnership success factor pieces that you're coming into in terms of who you're partnering with to get at those needs, or how you think about how you share value, which ultimately gets us to rate design and those types of pieces of this. How do you think about it?
I'll jump in. Our business is actually predicated on a lot of that, and the fact that you have to integrate different types of stuff. When you go into a facility, when you have to integrate PV with storage, with EV, with demand management, you're in a situation where there are multiple stakeholders, different equipment makes, models, vintages, all kinds of things. And then having to integrate that becomes a key challenge. So we not only have to deal with the sort of the technical challenge of what does integration mean. That is a deep problem, because it's not just a case of saying, and I know how to talk to this piece of equipment. You have to know how these things dynamically behave. So you have to have a much better understanding of those systems. That's the easy part. Working with the stakeholders is a completely different challenge, because we are in this evolving landscape where nobody has quite figured out who's stepping on whose toes, and the value chain that gets put together as the full solution gets put together, that's changing fast. So you are in this competition situation where you have to work with each other, but at the same time, you're kind of a little leery about each other as well. And I think that's good. I think that actually allows people to be more focused, be more competitive, bring better solutions to market, and understand the value of collaborating. So I think I've had conversations with many of the people here today, and essentially as we do these projects, there is a general recognition that you have to work together. And I think that hopefully is here to stay for the next many years as the deeper issues in the sector get cracked. And then once adoption picks up, some of those clear distinctions between different players in the value chain might clarify itself.
Absolutely. You seeing a similar thing?
Yeah, it was very similar. I mean, our customers are utilities, even though some of the benefits rendered ultimately also accrue to the independent power producers or retail providers in our case. But our customers are the utilities, and so we take a relatively simple view on this, which is we rely on our customers to drive which partnerships we actually spend time on, because at the end of the day, if we're not solving a problem for the utility, then partnerships is relatively meaningless in our case, right? And so that means, though, that you actually need to forge partners both with incumbent suppliers to those utilities, because that's where most of the infrastructure is today, and you also need to forge partnerships with the emerging suppliers. And that can be, as Sunil alluded to, a little bit of a tricky game. But again, I think a lot of that can be elucidated by having the customer in our case the utility, drive those interactions.
And how do you think about looking at that partnership and shared in what's a very fuzzy, evolving state, right?
Yeah, absolutely. I think, though, for us, it's also pretty important to, for instance, we recognize the customer sees the utility as the trusted partner, so collaboration with them in perhaps co-branding opportunities, something that we're interested in as well. We also have to work with them. We have the capabilities of delivering a particular flexibility to the system, but how can we define it in a way that's actually appealing to the utility as well? And I think that quickly starts getting into what I was touching on earlier. How do we, for instance, if the construct today is that utilities can earn a return on infrastructure, could there be a different paradigm where if they're contracting services and their services are being provided to the grid, can there still be a return for utilities to do that? So that's something we're proposing out there.
Yeah, no, absolutely. Well, I think that's a question that we discussed quite a bit, was how and why are services compensated for regardless of who's providing those things, right? And how do you guys think about the evolution of that? Is it in your business model? And he's not
I
going
hope
to tell
so.
me.
No, I think that particular question about how our service is structured, I think there is one previous step to that. How are we constructing anything using the physical distributed resources that we have access to? Right? So today there's a tendency to think about equipment as equipment. If it's a PV system, there's an inverter. If it's a backup generator, it's a genset with something on it. Storage, it's a battery. But instead, at any point of interconnection, if you can actually think about the system behind it as an energy system, right? So it's a virtual power plant, if you will, with certain characteristics. I think that step to actually being able to think about these systems as an integrated whole, as opposed to pieces of equipment, is a fundamental requirement there. Once you do that, now you can talk about services that are delivered at that node using very familiar constructs. We just have a 4-quadrant inverter, and you can say what the characteristics are, along with a few other parameters to define what can be delivered at that node. So it's actually relatively straightforward to generalize this for any node on the system. Right? The key difference is you no longer think about individual pieces of equipment. You look at what's actually delivered at that particular node. If you can do that, then we can come up with more generalized cases that are actually scalable. You can take it everywhere without forever debating the merits of a battery versus an inverter versus something else.
Right. Well, the whole question of who has the responsibility of caring about the performance of the individual assets versus at the aggregated whole, right?
Right. That last part is very important, right? You still have to measure and verify something.
Yeah.
It's just a question of what that is and how you do that. Those could have a significant impact on actually how the system can evolve.
Well, this is where I think service level agreements ultimately need to come into place, because the purpose of a service level agreement is to actually delineate what the performance at that interface needs to be, and there may be even penalties if performance is not met, either from the utility to the customer or the customer to the utility, by the way, because these interfaces are now or will evolve to be bidirectional. And so I think the key, though, is rendering all of these possible services we can envision down to relatively few parameters that describe them. And all the parameters can be different, but relatively few parameters. And the reason I think that's critically important is because if we're not able to do that, then we're going to rely increasingly on the regulatory bodies to actually prescribe what that service evolution is going to be. And that's going to be very difficult to do. Because to do that effectively will require them to not only to predict the nature of demand and how it's evolving, but it'll also require them to predict the nature of supply and how it's evolving, because they have to prescribe both price and cost. And so I think the key is going to be saying, look, there's going to be a basic service that everyone has access to and may build upon. And anything that's on top of that, that's value added in the sense that the customer wants it, that needs to ultimately be unconstrained and left to the extent possible, market forces to drive those things. But all being able to be rendered down to a relatively simple description of it.
Yeah. And I think that gets to some of the initial points you were making, right? Around some of the operations and
Yeah, so I think you're starting to talk about more just sort of like how you end up commoditizing that need so that it's kind of like any type of technology or portfolios of technologies can meet that need. And I think perhaps the best example I can point to is, for right now, there are some projects that are described in satisfying a need for, let's say, 10 to 11 hours. What if you were to tranche that in perhaps, 15-minute increments and set programs where you send grid signals to customers who have those assets, you aggregate them and allow them to participate and test that real, like you said, through service contracts, you validate that performance. So I think and there's a precedent for that. I think we don't have to look too far back. Let's say in California, when storage was starting to become a resource and trying to participate in wholesale, the CAISO came up with the non-generator resource where they reduced that minimum size and then reduced that tranche of time, the duration for which resources could participate. So I'm sure the CAISO is still looking at sometimes at a time whole 10 hours, but they meet that through these smaller tranches. So that's sort of like what we're trying to
think about. No, absolutely. Well, I think it's important, the point you're making, though, about the better we can get something that's aggregated and specified in terms of the need, the more quickly it can scale. Because if we're at every single device level, it'd be real difficult to move quickly, both on a regulatory as well as a provider side of these things. We've actually got a couple questions in that relate to some of the comments we've already had. So why don't I grab a couple of those before we dive back into our pieces here. Naimish, a question directly for you. Have you signed one of these service level agreements? And if so, can you disclose which utilities are pioneering these types of contracts? And are there any anecdotes you could share if it can't be that specific?
Well, keep in mind, we're not the service provider, right? We're a provider of hardware and software to the utilities to help them build a platform to be the service deliverers, right? So we're never the ones to do the SLAs between the utility and the customer. That's up to them. But I think we're starting to see some early signs of this in the CNI space. I mean, CNI, I would say, if there's anything close to an SLA in the utility space, it's with the large customers, because those are the customers that consume lots of power and things matter to them, and power quality and so on and so forth. So there are, in the strictest sense, there are already service level agreements. When you sign up with a utility, you're signing a set of things that is like a service level agreement. We don't think about it that way. But I would actually reiterate something that Carlos mentioned, which is the wholesale market is replete with these sorts of things. So there isn't, it is not necessary to go and reinvent the wheel for a lot of the mechanisms we're talking about here as applied to the utility customer interface. These things already exist in the wholesale markets. There's contracts between independent power producers and the wholesale market. There's contracts between the utilities and the wholesale market. So a lot of the mechanisms and underlying constructs necessary to do this already exist. They just exist at a bigger scale. And so scaling those down, altering them for the peculiarities of the distribution system is ultimately what's necessary. We don't have to reinvent the wheel entirely from scratch here.
I would like to add just another example that I think, I don't know if it's been overlooked, but we're positively encouraged by the utilities recently filed tariffs for their dynamic load management programs where they're enabling thermostats. And it's sort of like the first hint that you can see what REV intends to do for sort of like unbundling rates. There's payments there for reservation, for performance, and in some areas for targeted area performance as well. They're being very explicit about what the triggers are, whether it's an ISO SER event versus 94% of peak load. So we're positively encouraged about those, and I think as we start refining those, we're gonna get there. The minimum participation level for those as well, was reduced to 50 kilowatts. So I think that opens the door to more participants.
No, absolutely. That's a good example. A little bit of a twist on the things we've been talking about is how to think about energy efficiency in the context of DER platforms. This is a question that's come in from the room. Anybody want to take energy efficiency in the construct of the thinking?
Take a stab at it. When it comes to energy efficiency, nowadays you categorize them into sort of two buckets. You have passive energy, or passive energy efficiency and active energy efficiency. The passive stuff is really sort of the long-term changes you can make by replacing a light bulb. So that's kind of a fixed benefit you can get over the life of that change. The active stuff really looks at it from a systems point of view. So you may have the same light bulb, but depending on when you turn it on, there are certain efficiencies that you can capture. But the problem is that that efficiency is not captured right where that light bulb is, right? So it could accrue to this facility if you have a demand charge. It could accrue to the distribution network if there's some type of a constraint on the distribution network. It might be at the wholesale level. So there are different levels at which that particular type of efficiency can be captured. So looking at all the types of equipment and systems that are in place, being able to categorize between these two types of efficiencies allows us to capture, I think, efficiency in a richer manner than you normally think about.
I'd actually add even a third category to those two, which is, energy efficiency doesn't necessarily have to be associated just with an endpoint. It can also be associated with something a utility might do, a wires operator might do, to induce the same effect in the endpoint. There are programs called conservation voltage reduction programs that have been around since the 1980s that utilities have engaged in to manage their voltages so as to have that effect of reducing load, of course within compliant with it, while still maintaining compliance of voltage to the end customers. And so I think I bring this up only to note that there's multiple stakeholders, not just the end customers, that can participate and drive energy efficiency. And the means of compensation and pricing need to accommodate that fact.
Yeah, absolutely. I think looking at it, I think as Richard alluded this morning, just thinking about the customer bill, but as we think about the whole system, right? Where can benefit accrue? And how and why do you access that, right? And I think one of the original points you wanted to make as well around even just thinking about procurement relates to some of that. Where and how benefits accrue, how and why we define how people can participate and call in markets.
Yeah, absolutely. And I think, if you allow me just to jump to that topic a little bit, I think what we're referring to there is sort of right now, when you look at reliance on these resources, sort of like on the residual end, or sort of like, to match the last bit of your system need. And we're a little bit fearful that perhaps that may not really unlock the full market. What we're proposing is perhaps, and borrowing from ideas about a loading order, where you would tip that paradigm and invert it and say, how about you go look at the market first, of course, subject to cost effectiveness and best fit portfolios, and you look at whether you could meet a portion of that need with what customers can provide. And only when you haven't met a portion of that, then you go into like infrastructures or firm contracts. So something to consider, perhaps, flipping that paradigm around to really test what's the full participation you could get out of the market.
No, absolutely. The question coming in from the audience relates somewhat to supply-demand balances and around the, do you believe in the overgeneration duct curve postulated for California, and what does that mean from a DSP need to curtail? And I think it depends on how some of these pieces come together.
Yeah. Well, I mean, I don't think there's a need to believe. You just see it. This is happening. I mean, Hawaii, the regions I mentioned, this is a real phenomenon. And in part, it results from the fact that the incentives for solar in-feed largely ignore the demand side of the equation today. Net energy metering is provides for a fixed compensation independent of whether there's demand at that particular time or not. That's why you're getting net power flows back into the transmission system. If it was actually taking into account the demand side of the equation, then you wouldn't actually get the backfeed, or the systems would be dimensioned more appropriately for the local area that they're installed in. So I see no other option but for selective, albeit hopefully infrequent, curtailment of solar. Call it supply response, if you will, the sister of demand response. For the simple reason that the wires operators, the utilities, won't be able to maintain reliability of the system without doing so. And so there needs to be a mechanism in the SLAs, the contracts with the customers, and the compensation, the pricing, that is, of the services, to account for these emergency situations where there will need to be curtailment. And perhaps there's penalties applied in either direction if that needs to be done. Perhaps there's not. But without curtailment, the Germans, Californians, Hawaiians won't be able to deal with this problem.
Yeah.
I have a slightly...
Okay, we're in our last 4 minutes, so we're speed disagreeing
Sure.
now.
I was just going to mention that you have to be aware also of regional differences. I would encourage you to also look at the New York ISO is going to be performing very similar story to what California did, and I would suggest that perhaps the ramp needs here in New York are not as marked as in California, and the flexibility of the system here is way higher compared to California. The other thing to bear in mind is where the impacts are coming from, whether it's large-scale solar versus distributed. So just putting it out there.
No, absolutely. And so that does get us to, here we are today in New York. We've got lots and lots of things we've been talking about that have happened already there, and we are looking forward to the future. What would be the things you guys would be most excited about happening from the state perspective going forward in this particular, enabling this particular piece of the space? And it's the, okay, we got 2 minutes.
2 minutes.
2 minute drill.
30 seconds. Let me build off of the previous duck curve question there to answer that. I think the duck curve is a function of the rules that are in place, not a function of the equipment that's in place. Yeah? So relative to REV, I think the way to deal with that is if you can create the equivalent of the appropriate Tetris blocks, you can essentially refill the duck curve in a completely different manner. I think the challenge for REV, and I think the exciting potential for that, is that that's what we are setting out to do, right? Essentially to utilize existing resources, utilize distributed resources, construct the right ways to actually, what are the right building blocks, and what's the transaction mechanism to dynamically make sure that we have a relatively level outcome that you're actually looking for. So I think that's what I think the exciting part is, to create those blocks and the rules that go with it.
All right, I'm getting him a Tetris set.
No, I largely agree. I think there's really two pieces that this demonstration phase is critical, but I think it's critical not only in demonstrating the technology and what can be done with technology, if so appropriately applied, but I think equally, if perhaps not more importantly, is the fact that the rate design changes that need to occur to be able to provide the right economic signals and incentives for both the independent power producers and the utilities is absolutely essential. Because if we don't have that, we'll be doing demonstration projects for the next 10 years. There won't be incentives for the change.
Absolutely.
Yeah, and I couldn't agree more. I think I would like to point out to something that's going on relatively quietly in California. It's a new IDR proceeding, and I think it relates to the conversations we've had here in REV. I think they're very encouraging around the area of planning and how you consider these alternatives. The IDR is a proceeding to really unlock the mechanisms that are going to allow you to source those resources. So it really applies to what you were mentioning here, and we're pretty excited about that in California.
Good, very good. Well, the last and final, the one takeaway that you want the audience to remember.
Sunil?
The one thing, from my perspective, would be virtualization. Think about virtual resources as the transacting fundamental unit. The rest of the stuff that we've been talking about, you can build off of that. But if you don't get there, then we'll create a harder problem out of something that's fundamentally simpler.
I'll build on that. I like virtualization, and on top of virtualization needs to be a means of pricing those virtual resources. And again, I'll reiterate, we don't need to reinvent the wheel here. There are mechanisms already in place that have proven themselves at scale in the wholesale markets that can indeed be applied here.
And for me, I would just say we're very actively seeking to collaborate with the industry to really try to figure out these challenges as well. So I really welcome partnering with you.
Excellent. Well, hopefully this is helpful in unpacking what is a very complex and important subject. So thank you very, very much for joining in this. And join me in thanking the panel. Thanks, guys.